Alrighty, welcome back to Fun Maths. Today we're looking at antidifferentiation. Now, in the past videos we've looked at differentiation. Obviously the process of going back the other way is known as antidifferentiation. So what they're saying here is if you have a derivative of x squared with respect to x, it's 2x. If you wanted to go back the other way and anti-differentiate that, and you had the derivative 2x, then clearly the unknown expression could be x squared. And the process of finding that derivative is called antidifferentiation. Now, here's where it gets a little bit unusual. You could have two functions. We've said f of x here, and we've got g of x. If you were to differentiate both of these, obviously here the x squared part differentiates to 2x. This differentiates to 0, so the derivative of this here is 2x. Likewise, if we do the same thing, we differentiate this function g of x, the derivative is going to be 2x here plus 0, or just 2x. So they're both, the derivative of both of these is 2x. Now, if we had both x squared plus 1 and x squared take away 7, and you wanted to go back the other way, they are both said to be antiderivatives of 2x. Yep. So because they're derivatives of 2x, the original functions are the antiderivatives of 2x. Now you can see here, if you've got two functions that have the same derivative, then they're going to differ just by that constant. So you've got the graphs of two functions can be obtained from each other by translation parallel to the y-axis. And we can see here several antiderivatives of 2x. Now, here is how we start writing these things out. We say the general antiderivative of 2x is x squared plus c. Now it's important to put this plus c on here because that c is going to be that arbitrary real number. Yep, that constant value on the end. And using Leibniz's notation is as follows. This notation says the following. This is the general antiderivative symbol. So it says the general antiderivative of 2x with respect to x is equal to x squared plus c. Another way they might refer to this is the indefinite integral of 2x with respect to x being equal to x squared plus c. Okay, so if you're asked for the general antiderivative or the indefinite integral, this is the sort of notation that you're going to be using. In general, there's a rule. It says if you have, and we use the big F here, the antiderivative of the derivative is going to be the original function. Yeah, that's what that's saying. And so forth, what we're going to be saying here is, again, you'd be saying the general antiderivative of f of x with respect to x is equal to bigger f of x plus c, where c is the arbitrary real number. Alright, so here are some of the rules for antidifferentiation. We've looked at differentiation. So, for example, if you had a function x cubed, if you were to find the derivative of that, obviously we multiply the number out the front by the power, so that becomes a 3, and we take away 1 from the power. The derivative is 3x squared. We can find each of the derivatives, so forth. Yep. Again, this is just the general here. If you have x to the power of n, the n comes down or multiplied by the front, and we take away 1 from the power. That's differentiation. I guess by looking at this, we could say if we were to get the antiderivative of this, it should go back to this here. Yep. So let's look at reversing that process. If we have the general antiderivative of 3x squared with respect to x, obviously it's going to be equal to x to the power of 3, but you have to put on this plus c on the end, which is that constant, arbitrary constant. Yep. We need to get in the hang of putting on this plus c. Later on down the track, if we're given more information, we can find out what c is, but when you're just finding the general rule, we just leave it as plus c. Again, you can see how each of these is going to work out the antiderivative and going back this way. Notice they've all got that plus c on there. So, generally speaking, here is the rule for antidifferentiation. If you are going to find the general antiderivative or the indefinite integral of x to the power of n with respect to x, what happens is you're going to be adding on 1 to the power. Then you're going to be dividing everything by the original power plus 1. And we'll get the hang of this in a moment. Don't forget, we need to put this plus c on the end always. Now, like we were doing with differentiation, if you've got the sum of each of these parts, you work out each of the antiderivatives for each of the parts and you add them together. Likewise, if you're subtracting them, you work out the antiderivative of each of the parts separately. When it comes to multiplying or the multiple, if you've got a constant value out the front of the function, that k value can come out the front of the antiderivative, and then you can just antidifferentiate the function f of x. And we'll have a look at an example of that. Alrighty, so it says here, find the general antiderivative or indefinite integral of each of the following. So we've got 3x to the power of 5. So, using the multiple rule, this 3 here is the k value, it can come out the front. Then you're just left with the function x to the power of 5 to work out what the general antiderivative of is. So if you do it this way, the 3 lives out the front, we're now just going to find out the antiderivative of x to the power of 5. Obviously, again, using the rule, we add 1 to the power. So adding 1 there, we end up with 6. And then we're going to be dividing by the power plus 1, which is 6. So we're dividing by 6 also. When you are going ahead and doing this, you've got the 3 on the top line, you've got 6 on the bottom line. That does cancel down to 1/2. Yep. Don't forget to put this plus c here as well. Now, whether you do it this way, or you could just say, like according to the rule up here, adding 1 to the power, that's 6. So it's going to be x to the power of 6. And then we're going to be doing this number out the front divided by the 6. 3 divided by 6 is 1/2. You can sort of just skip that and jump to there. But it's important to know how that works. Likewise here, this is a addition or the sum sort of circumstance. So here you've got different parts added together. We just need to work out the antiderivative of each of those parts and put them together at the end. Yep. So you're working out the antiderivative of 3x squared. We're adding 1 to the power, so it becomes x to the power of 3. And then we're dividing by that new power, which is 3. 3 divided by 3 is just 1. So you end up with 1x to the power of 3 for that part. Here you've got 4x to the power of 3. We add 1 to the power, so it will become x to the power of 4. We're going to divide by that new power. 4 divided by 4 is just 1. So you'll get the hang of it quickly, and you'll sort of be able to just skip sort of from this step down to here. Yep, they're just showing all of the working out here and the thinking. Here you've got 3. This has really got an x to the power of 0 here, even though it's not written. So again, the rule still applies. You're adding 1 to the power, so it'll become x to the power of 1, or just x. And then we're dividing by that new power, so dividing by 1. 3 divided by 1 is just 3. So you end up with 3x here. Don't forget, always put that plus c on for these indefinite integrals. Okay, so that's good news. Should be able to have success there with those. Next one, it says if you're given extra information, then you can find an actual unique antiderivative rather than just a general antiderivative with that plus c on the end. So for example here, it says it's known that the antiderivative, or sorry, my apologies, it is known that the derivative, f dashed x, is equal to x cubed plus 4x squared. So we've got a derivative, and they want us to find the original function. Yep, so we need to anti-differentiate. Good news though is they've given us this additional information. They're saying f of 0 is equal to 0. And we can use this to work out what the value of c is. So first thing we're going to do is anti-differentiate this derivative to get back to the original function. Yep. Antiderivative of x to the power of 3, we're adding 1 to the power, so it becomes x to the power of 4, and dividing by that new power, so 4. So x to the power of 4 over 4. This one here, we are anti-differentiating, adding 1 to the power become x to the power of 3, and then dividing by that new power of 3. So you end up with 4x cubed over 3. Don't forget to put that plus c on at this stage. Now, we've got the original function, but we want to find out this c value. So this additional information is saying is when we substitute 0 into the original function, it comes out to being equal to 0. And so if you were to substitute 0 into here and evaluating to 0, we know that rearranging it, that c has to be equal to 0. Yep. So we found out that c is equal to 0. You can plug that into the final equation rather than writing plus c on the end. You could write plus 0, but even better than writing plus 0 is just you don't need to write anything at all there. If it was another number that wasn't 0, you would see it either added or subtracted on the end here. Yep. Alrighty. Oh, this is cool. It says here, if the gradient of the tangent at a point xy on a curve is given by 5x, and the curve passes through the point 0, 6, find the equation of the curve. Cool. So really, we've got the tangent of the curve given by 5x, which is really saying we've got the derivative. Yep. Or the gradient function. So if we've got the derivative and you want to get back to the original equation, you need to anti-differentiate it. Good news is we can anti-differentiate 5x, but even more exciting is that we do have some additional information, so we should be able to find out what the c value is and find out exactly what the original equation was. So let's first of all anti-differentiate 5x. Okay, so we're going to raise, the power is x to the power of 1. We need to add 1 to that power, so it'll become x to the power of 2, and then we need to divide everything by that new power. So it'll be 5 x to the power of 2 over 2 is the antiderivative. Oh, plus c, don't forget that. Now, once we've got the original function, we've got some additional information that says that the curve passes through the point 0, 6, which is another way of saying is when you substitute 0 into the function, it comes out to being equal to 6. So we've got this function here. If we plug 0 into here and we make it equal to 6 and you rearrange things, you will find out that c is equal to 6. Once you find out what c is, rather than writing out the function with a plus c on the end, because we know what c is, you can put that value in there. So they've written out 5x squared over 2 plus 6. Cool. Last thing I want to have a chat about is these ones here. Again, just a little bit different notation. It says find y in terms of x if dy dx is equal to x squared plus 2x, and they're giving us some additional information. We've got y is equal to 1 when x is equal to 1. So again, we've got the derivative. We are going to be required to find out the antiderivative to find out what the original function was, and then we can substitute these in to find out what that c value is. So working out what the antiderivative of x squared plus 2x is, antiderivative of x squared, add 1 to the power, so it'll be x to the power of 3, and then divide it by the new power, which is 3. 2x is the same as when we're anti-differentiating it, we're going to add 1 to the power, so 1 plus 1 is 2, and then we're going to divide it by 2. If you've got the 2 divided by the 2, that's the same as 1. Cool. We have the equation y equals x to the power of 3 over 3 plus x squared plus c. Now we're going to use this additional information to find out what this c value is. Where you see the y, you can substitute in the 1. Where you see x, you can substitute in 1, and we can rearrange, and we find out that c is equal to -1/3. Excellent, we've got this c value. We can write out the equation, but popping on what we know the c value is on the end, which was -1/3. Likewise here, we've got another expression to do. We need to find out the antiderivative of this here. Again, this is 3x to the power of 0. Adding 1 to the power, it's going to become just x, and dividing by that new power of 1, so you'll end up with 3x over 1, which is just 3x. Negative x, we need to add 1 to the power, so it become negative x to the power of 2, and then this needs to be divided by that new power of 2. So you've got negative x squared over 2. We've got that plus c on the end. We've got some additional information so we can find out what that c value is. As it says, y is equal to 2 when x equals 4. So what we're going to do is plug 2 into where y is here, and where x is, we're going to substitute in 4. We're going to rearrange things, and we're going to find out what that c value is. Oh, cool, it's negative 2. We can then write out the equation, but where this plus c is, we can put down what c is. So it's negative 2 on the end there. Alrighty, thank you very much for listening up. There is a summary of the sort of things that we've spoken about here. The rule for antidifferentiation, just recapping, we're adding 1 to the power and dividing by that new power. Don't forget to put the plus c on the end. And again, if you've got to antidifferentiate parts where we've got sums, you just antidifferentiate each of them and write them all out. Likewise, if you've got to work out the antiderivative of differences, you just work them out individually and then write them all out. And we spoke about what happens when we've got the multiple scenario. This k value comes out the front, and you just antidifferentiate the function. Bye for now.